Hi, my name is Sebastian Kleetsch, and today I'm talking about structural steel design with SolidWorks, especially using solid steel parametric. At first, I'm going to talk a little bit about the Kleetsch GmbH. That's the company, the development company of solid steel parametric. And after that, we jump right into the software itself. We take a look at the functionalities, at the benefits, and especially a look at the stairs and the handrails module, which is already included in the smallest package. The Kleetsch GmbH, who are we? We are a software development company based in Germany, or headquarters is based in Germany. And we are a classic family business, a family-owned software development business. We are on the market almost 50 years. Next year it's 50 years. And in the early 80s we started with a software development for structural steel design as add-ins for standard CAD systems. In the early 80s it was ME10 from Hewlett-Packard. Today it's SolidWorks, Siemens NX and the Creo products. Over the years we were able to sell thousands of licenses, and we have more than 1,500 customers around the world. These customers are small engineering offices with just one employee, or big global players like Liebherr, Enercon or Herrenknecht. The product today, or the product we want to talk about today, is solid steel parametric. It's a classic add-in for SolidWorks. That means it's integrated into SolidWorks. Not only integrated in the user interface, it's also integrated as we are using standard or native SolidWorks parts. We are creating native SolidWorks parts. We are creating native SolidWorks assemblies. So you can work with SolidWorks PDM, for example. It's fitting into the existing IT infrastructure of your company. Of course, it's a modular software solution. That means there are different packages available with different functionalities included. But even in the smallest package, the engineering package, already the profiles are included, all the steel connections are included, and even the stairs and handrail functionalities are included. Today, we are going to design this small frame here. It's a support frame for steel coils or paper coils. And now I'm going to show you how easy it is to design such a steel frame with solid steel parametric for SolidWorks. Everything in solid steel parametric is based on a SolidWorks sketch. This can be a 2D sketch or a 3D sketch. And at first we are going to create some beams. To do that, we just select some lines. And as you can see, a preview immediately appears. Of course, the beams can be rotated and placed in different positions regarding the system line, but it's very easy and very intuitive. Okay, as the next step, we just create the beams we need for the bracings. We can create all the four at the same time. We just have to rotate them. And we just have to assign a parallel offset, and then the beams fit together as we want them. Okay, now all of our beams are ready and we are going to connect them to each other. First we use the end plate function. We just select a source beam and the target surface, selecting an end plate. And if a fitting size is in the database, we get everything together, including the bolts and everything. We just repeat that 4 times for the columns. Okay, in the next step, we just create some stiffeners at the end points of the columns. It's very easy. Just select a beam where the stiffener should be placed in, and then select the position of the stiffener, and it's done. Of course, from the stiffener and the beam, a welded component assembly will be created automatically if you want that. That means that all parts which are welded together are stored in one sub-assembly. Okay, as a next step, we just connect the bracings and the columns. We use the gusset plate function here. I already stored one in my presets, and as you can see, it's super easy. Just pick it out and everything will be done. The gusset plate will be placed, the welded component subassembly will be created, the bore holes will be created, and of course the bolts, nuts and washers. I just repeat that 8 times or 7 times for all the other bracings and the columns. Okay, that was the last one. As a next step, we create some base plates for the columns. We just have to select the beam and we can change the size, the dimensions, the hole pattern, of course, the way we want that. In our case, I want it a little bit bigger, and I'm just editing the width or the offset on the left and the right side of the beam. In the next step, I'm adjusting the position of the hole pattern. To do that, I'm just changing the amount of bore holes, and if I get back to 2, they are centered or aligned to the middle again. Okay, that's the right size. Of course, the base plate will be stored in the welded component subassembly again. Because we need this base plate more often, I just store it as a preset so we can reuse it for the other columns. Okay, selecting another column, just have to switch the beam end and selecting the preset, and you can see the base plate is correct now. All right, now we finished our design, or better to say, the steel part of our design work. And in the next step, we want to take a closer look at the following processes. We want to create a bill of material and some shop drawings. To do that, I first update the metadata. That means that all the necessary information like length of the beam, beam type and everything will be stored in the part properties of each individual part. In the next step, we are going to export a bill of material into Excel. I just selecting a template, how my bill of material should look like, selecting a storage path, and let's take a look at the result. Okay, here's our result. We have a bolt list, for example, just a summary of all parts, just the sheet metal parts, just the beams. We have a structure list which contains the structure of our assembly levels, and a cut list. Of course, in this case we don't have angled cuts, so it's empty. The next step, we create some drawings. I just select 2 components that you can see how that works. Selecting a template, it's a standard SolidWorks drawing template, and we assign an order number. Now you can see the drawings are created fully automatically, including all the dimensions we need. But because it's so fast, let's take a detailed look at a drawing. Let me just open one. Okay, here we have our bracing beam, and you can see all the dimensions for the bore holes and everything you need for manufacturing. If you need DSTV and C files for manufacturing, we can do that with the DSTV assistant. In our case, all the parts are identified, of course. We have the L beams, the I beams, and down below the sheet metal parts. Okay, we were able to see that we can cover the entire process chain of steel design with Solid Steel Parametric for SolidWorks. At first, we have all the different libraries. We have international profile libraries. They can be extended in any ways, different sizes, different cross sections, everything. And here we can see the different standards which are in delivery. We have the US standards in millimeter and inch. We have the European, UK, Russian, Australian, and also the Chinese standards. The steel connection, Solid Steel Parametric is able to create more than 500 different standard connections, no matter if it's a welded or bolted connection. Using the assembly manager, we can create bracings and all different other assemblies multiple times. So we are working template driven. The stairs and handrails module can create industrial stairs with just a few clicks, fully automatically, all the beams, all the stair steps, the bore holes, everything. We have, of course, a library of different stair steps. And the handrails, again, there are thousands of different types of handrails. So Solid Steel Parametric offers the possibility to use templates for that. Just create your type of handrails one time and then reuse it as often as you want. And we were also able to see the different following processes. We have automated numbering for bills of material. We have a detection for similar parts. We can create shop drawings. We can work together with software for structural analysis. We can do the DSCV and C export. So there's everything possible. The entire process chain from the first idea until the manufacturing data, you can do that with Solid Steel Parametric. In the next step, I want to take a closer look at the stairs and handrails module of Solid Steel Parametric, because especially stairs and handrails are a really time-consuming part of the design work. There are so many calculations possible, the different angles, the sizes, the steps, everything. So we need a functionality who helps us doing this. Of course, there are different regulations in the world, but also maybe different regulations from project to project. And there are, as I've mentioned before, endless types of handrails, and we need a solution for that, how to make it possible for you. Let's take a look at the stairs and handrails functionalities live. As we saw in the previous model, we start again with a standard SolidWorks sketch. We use the stairs function of Solid Steel Parametric and just select the beginning and the end point of the stair. Immediately we get a preview, and I just change the profiles of my stingers using a European U-shaped beam, maybe a bit smaller one. And now I want to change the step size, just a bit wider one, and let's go deep into it. First of all, I set an offset to the right, and next we want to create some extensions, first at the top side, 1000 millimeters, and at the bottom size a vertical one of 180 millimeters. Okay, on the left side you can see the different calculations, so let's make it a little smaller. Okay. In addition, an additional step at the bottom side, and okay. Creating the stair takes just a few seconds, and you can see that all the profiles are created automatically, the miter cuts are done, the stair steps are placed, the bore holes are created, and of course the bolts, nuts and washers are also placed automatically. All right, here's our finished stair, and now let's move on with some support structures at the back to mount it to a wall or something else. First we create a U-shaped beam again, and using the standard offsets of solid steel to take it into place, to bring it into place. A miter cut at the end, and a face cut here with an offset because we want to connect it with a clip angle later. Okay, Now the clip angle, just selecting both surfaces. I just select one from the presets. It's a European standard, and just selecting the bolts, again European standard, but you can see there are a lot of different other standards available. Bigger one. Okay. Get a default mounting set, and okay, that's the way I want it. Okay, in the next step we want to take care about our handrails. To create a handrail, we just select a connecting surface and an edge. Now in green we see the bounding box of our handrail type, and we can just change some settings, the offsets at the end and at the beginning of the handrail, and of course the distance between the connection and the beginning of the handrail. Okay, when we click apply, our template will be used, and Solid Steel Parametric is creating an independent copy of our template. So we can change it in the design in any ways, but the template itself will not be affected like that. For example, now we have the 4 different segments. We just want to have 2 and change it the way we want it. Maybe not 10 rods, let's take 7, click apply, and the template or the handrail will be adopted to the new situation. You can see it's super fast and super efficient to do that. At the top side we are going to create another segment of our handrail, and I want to show you how to combine 2 segmented handrails into one consistent handrail. Okay, just changing the offsets again, also at the start point, to get an overlap of both columns. Why we do that, you will see in a minute. Okay, here's our handrail again. We just want to change it into one segment and 7 rods again, and like this. Okay, now we just hide the columns we don't need. We can maybe suppress them, but hiding is okay in this case. Okay. In the next step, we are selecting, or we are connecting the first segment or the second segment to the first column. This one also, of course. And now we just need a miter cut for our handrails. Okay, just selecting both beams first and the second one. Okay, that's it. So it's super easy to create even complex types of handrails. It can be also one with a glass segment or something else. So there are absolutely no limits to your creativity. Yeah, of course we can also do it or around corners or something else. I just don't show that because it's obviously the same we did it before. All right, that's just a rough overview about all the different functionalities of Solid Steel Parametric for SolidWorks. There are so many additional things. We have an entire facade module we didn't talk about today. There are so many different connection types, so many interesting features. But just contact us if you want to learn more about that. We are also available at the virtual and the physical 3D Experience World 2022 in Atlanta. Just visit our booth and ask us. If you are not able to visit us in Atlanta or on the virtual event, just check out our websites, our YouTube channel, LinkedIn, Facebook profiles. We are always happy to share our information with you. Take care and have a great event. Thanks for watching.